Hello, in today's video I'm going to be talking about gravity and specifically looking at gravitational potential energy. So, gravitational potential energy can be described as the energy an object possesses because of its position in a gravitational field. When studying potential energy on Earth, it is pretty simple because we can use gravitational constants. However, we now need to expand that that definition since we will now be looking at outer space. So previously we used potential energy is equal to mgh, but now we're going to need to specify that a little bit more. So since gravity is a conservative force, we can find the gravitational potential energy from the definition of potential energy. Essentially, the formula for gravitational potential energy, or the more general formula for potential energy, is U is equal to, where U is the symbol for potential energy, negative gm1 m2 over r. So that's just a basic outline of what gravitational potential energy is and the formula that can be used to calculate it. So I'm going to go ahead and apply this concept to an example from an AP exam. This problem is part of a series, so I strongly suggest that you go watch the previous two problems, number 24 and number 25, before you continue with this one, or even after. So the problem reads, two satellites of masses m1 and m2 orbit a planet of mass m in circular orbits. The satellites travel in opposite directions with speed v1 and v2, as shown in the figure above. Their orbital radii are r1 and r2 respectively. Assume that m is greater than m2, which is greater than m1. So I'm going to go ahead and diagram this for you. So we've got our m here, orbit 1, and our second orbit here. And we've got m1 here, and v1, and m2, and v2. And then we've got r1 here, and r2 here. So I'm going to go ahead and read problem number 26. It reads, if U1 is the potential energy of the planet-satellite system containing the system of mass m1, and U2 is the potential energy of the planet-satellite system containing the satellite of mass m2, which of the following expressions best represent the ratio? So we're going to go ahead and look at this formula to solve this problem. So the potential energy of MP and M2 mass system separated by R is given as U is equal to negative GM M1 over R, which is, and then U2 is equal to, U1 is equal to that, U2 is equal to negative GM times M2 over R. Again, we're looking for the ratio of U1 over U2. So we get U1 over U2 is equal to negative GM M1 over R divided by negative GM M2 over R. The negatives cancel out, the R's cancel out, the G's cancel out, and the m's cancel out, and you're left with is equal to, oh sorry, this is R1 by the way, and this is R2, so it's R1 and R2, so they actually don't cancel out, my bad, but everything else cancels out, so we're left with M1 R1 divided by M2 R2, which becomes M 1r2 over m2r1. And then we go ahead and we check to see if that corresponds with any of our answers, and we see that it does. It corresponds to option C on the exam. Thank you.